Working with data in the Dataverse using Power Automate is really straightforward. There's lots of actions to use. But when you list rows in the Dataverse, often you're a bit limited to what you can check and validate before you get that data back. But in this video, I'm going to show you a shortcut that lets you look not only at the data in the table where you're interested, but also at the values of related tables. Here's a common setup. You've got a project table or whatever entity it is you're working with. You've got columns. This is my project name. Sometimes you'll have a column which is called a lookup column. Here, the lookup is department. So each project is associated to a department. The department itself is another table entirely. And you can see here it's configured to link to this department table. Here's the department table. It's just got the name of the department and a budget limit, so a piece of data there. With that in mind, to go and list the projects based upon whether their associated department has a limit that's suitable, for example, is quite straightforward. You have a tool called OData, and what I've got here is a filter that looks at the department and the budget limit of the department which is related to the project row. So what we effectively have here is a department which is the one side of a data model and the many side which is the project, and we're saying for the project I'm looking at, go and find its related department record and go and find on that one row exactly what the budget limit is. Really quite straightforward, and here's the syntax. So although we're filtering the project table, we're actually going to go and filter on the name of the department table, which is TPG dept, and then the field on that table. Just to bring that to life, here's the department table, here's the budget limit, and here's the column we're talking about. If we look at advanced options, it's the logical name that gets used. So you'll see it's all lowercase there for me. So this will effectively go and look at any project and list it out where the department that's associated, so one of these, has a budget limit which matches the criteria. And in this case, the budget limit's got to be greater than 7,000. So what we're looking for really is any project that's for department 1 or 3. None of the department 2 projects should be listed. Let's pop a terminate in and run this. The terminate's there just so we don't go to the next step. When that's run, we can have a look at the data that's been retrieved. If we look carefully at the body and pay attention to how many values have been returned, we actually only have one. And if I look carefully at this one, I can identify it's a project called PACE. So remember, department 1 or 3, and the project called PACE is department 3. As you see here, there are no other departments that are listed against projects, so that's returned the right value. So that's really nice and easy and a really common query that you're going to want to do. And remember, what you can do is you can look not just at the data that's in the specific table, but because of that lookup, I'm able to look at related tables. But in this case, the relationship is going from the side of the many to the side of the one. So there's many projects which are linked to one department, and then it works as OData. But what if that is not the case? If we flip that on its head and we start to say we only want to get back departments that meet a certain criteria, but also only ones that have got projects linked to them. So we're going from the one side and looking down at the many as well to encapsulate all of that in our filter. Things get a little bit more complex. We can still do it with OData. And here's the syntax that I'm going to show you here. A little bit more involved, but again, we're just looking at the column on our department table, the budget limit, greater than 7,000. But instead of just a simple column name on the project table, what we have to do is we have to reference the relationship between the two tables. You'll see that slightly longer. And the way you find this, in my case, I've got this lookup from the project to the department. If you go into your lookup columns, you will find, if you look in the advanced options, the relationship name, and that's what I've copied and popped into the OData here. And then you're going to use a special operator, and they call these lambda operators. There's any and all. But for OData, you want that / and the word any and the open close brackets. What that's really saying is, I want you to give me back the department rows where I've got a department budget limit of 7,000, which we know to be one of these two. But equally, I only want you to give me a row, so department, where there's an associated project. So just a quick look at the data again. we know that is the case, that there's no project for Department 1, so that wouldn't be bringing back. Department 2 has a lower threshold, so Department 3 should be the only project we bring back. Let's give it a test. And with that run, let's have a look at the outputs. And again, we've got the value coming back. We've only got one of them, so it's nice and easy to see. And we can see there it's Department 3. It's the only record it's brought back. So you can see you can go from the many side and you can go from the one side, but you have to be a bit more careful about your relationship declaration. If you don't fancy delving into OData, because it can be a little bit awkward and a little bit fragile from time to time, there is another secret weapon. And I use this a lot, even for some of the simple queries, purely because my brain works very well with it. And that's a tool called Fetch XML. So you'll see here, I've created a compose, and you can use AI to help you, or you can learn Fetch XML. It's not overly complex. It's effectively creating the right kind of structure for a query that you're going to perform. So here, I want you to get me the distinct rows. I want the entity that you're going to search in to be TPG department, my department. And then I want you to bring back, and again, inside this filter here, I want you to bring back everything where it matches. So the and is the inclusive operator there. It matches the budget limit equal to 7,000. So it's quite easy to read when you see that. But additionally, what you've got is a superpower with Fetch XML where you can extend it to go and traverse into different tables. And here I've got a comment. That's the structure for comments. But what I'm doing here is saying, go and link an entity, and the entity's project. And I want you to go and link from the department to the department ID in the department table. You see, for my own benefit here, I've written down which side is which, but do some experimentation. If you want me to copy paste this Fetch XML so you can try it, I will do. But you also declare the kind of join. And what that's really saying is, go and get me the department that matches the criteria, but also one where there is a project that's linked. So let's give that a run, but let's see what we get back. So again, let's have a look at the outputs. And again, we've got one value back and it's Department 3. So it's produced the same result as the OData, but for your brain, it might work better to try and experiment with Fetch XML. There's a lot of flexibility in Power Automate and it's always changing, always getting updated, but keep checking back for videos like this to give you little tips, little insights of things you can try to try and find those little shortcuts that work for you. See you in the next one.